Hello guys, welcome to our channel. I am Lara, and in this video we are going to talk about gravity method. So what is gravity method? The gravity method is a quantitative technique used to determine the optimal location of a facility by considering the coordinates of demand points and their associated weights. It calculates a weighted average location that minimizes total transportation cost. Okay, and now here we have the formula for the gravity method. I'm not going to go in depth here because we're going to solve a question. We're going to see it there. Okay, so our example. A logistic company is planning to build a new distribution center to improve its delivery efficiency. The company serves 3 major cities, each with different locations and shipment volumes. The current coordinates are City 1 is at 37, City 2 is at 75, and City 3 is at 92. The cost per unit distance is assumed to be the same, while the number of trips made per day are 3, 5, and 2 respectively. The company wants to determine the best location for the new distribution center using the gravity method. Okay, so when we see how many trips per day are made, then we are going to have to think about weights directly. So the weight of city 1 is going to be 3, weight of city 2 is going to be 5, and weight of city 3 is going to be 2. So let's solve the question. Okay, so I already have a tableau here. We're just going to put all the other values in. So what we are going to do is, already we saw it actually in the formula, we are going to see x star and y star value. So to do that, we have to remember what x star and y star was. So x star was the summation of the multiplication of the weights times the x-coordinate. So yi times xi, and then we're going to divide that by the weights. So vi. And the same goes for y star, which is going to be the summation of the multiplication of the weights times the y value. And then we're going to divide that by the weight. Okay, so how do we do that? Let's calculate first yi xi value and yi y value. Okay, so 3 times 3 is 9, 7 times 3 is 21, 7 times 5 is 35, 5 times 5 is 25, 9 times 2 is 18, and 2 times 2 is 4. So this is already halfway. So we are now going to find x star value. So we are going to have to find the total value first. So let's calculate 3 plus 5 plus 2 is 10. 9 plus 35 plus 18 is 62. And 21 plus 25 plus 4 is 50. So now that we have these values, let's calculate x star. Okay, so 62 divided by 10 is 6.2. And then we have y value, which is going to be 50 divided by 10, which is going to be 5. So from the gravity method, we can see that our optimal location is supposed to be in the coordinates 6.2 to 5. But unfortunately, in real life, we don't always have a open plan, let's say, that we can just build somewhere when it's the optimal solution, because our optimal solution might already have a facility there. There might be a school already there. There might already be a supermarket or a house. There might already be a building. So what we're going to do is we are going to look at our options. Optimal point was 6.2 to 5. But to make it easier for myself, I'm going to say 6 to 5. I'm going to use this one. So what we are going to do now, we're going to look if the other points are, which of the other points are more optimal, more feasible for us? Which one is better for us? So first we're going to have to calculate the f value for the point that we already have, for f6, 5. So basically what we're going to do, we're going to use the formula that I have written below. That's the only thing that we're going to do. So the weight, let's remember the weights. Weight 1 was 3, weight 2 was 5, and weight 3 was 2. So I'm going to say 3 times the x value is 6 minus 3 plus y value minus 7 plus a city 2, 5 is the weight, and then 6 minus 7 plus 5 minus 5 plus 6, 2, 6 minus 9 plus 2, 5 minus 2. Okay, so this part is 3, this part is 2, this is 1, this is 0, this is 3, this is 3. So 3 plus 2 is 5, times 3 is 15, plus 1 times 5 is 5, plus 3 plus 3, 9, 18. Yes. Okay, so this is going to give us 38. Let's continue. For the yellow dots. So what do we have here? We have 1, 8, 2, 4, and 6, 8. These are our possible options. So let's start with 1, 8. So again, first we city 1, 3 times 1 minus 3 plus 8 minus 7 plus 5 times 1 minus 7 plus 8 minus 5 plus 2 times 1 minus 9 plus 8 minus 2. Okay, let's calculate. 1 minus 3, 2, 1, multiply it, 9, plus, this is 6, this is 3, 9, 45, you already see it's larger, and then what we're going to get had above, 8, and then 6, 14, 28, and this is going to give us 82. Okay, then F24, F24, so again, 3 times 2 minus 3 plus 4 minus 7 plus 5 times 2 minus 7 plus 4 minus 5 times 2 times 2 minus 9 plus 2, sorry, 4 minus 2. Okay, so 1, this is going to give us 3, 4, 12 plus 5, 1, 6, so 30, 7, this is 2, so 18. This is going to give us 42, 60. Okay, and the last one, F 6, 8. Okay, 3 times 6 minus 3 plus 8 minus 7 plus 5 times 6 minus 7 plus 8 minus 5 plus 2 times 6 minus 9 plus 8 minus 2. Okay, so this is 3, this is 1, 12 again, and then 1, 3, 20 plus this is 3, this is 6, 9, 18, and this is going to give us 50. So as you can see, none of these are better than 38. They're all larger than 38. So what we're going to do, we're just going to kind of eyeball it. Not eyeball it, we're going to use Euclidean distance. So what did we have? 6, 5. So it's here. Already, actually, if you look, that 6, 8 is the better option. And you can already see that also because it's the lowest number. So what we have to do is, if we can, we should open a facility at 6, 5. If not, if really those three are our only options, then we are going to have to go to 6, 8 to open the facility. Okay, so thank you for listening. If you want to test yourself about how much you have learned in this video, then you can scan this QR code and solve the questions that we have prepared for you. Thank you for watching. See you next time.